Hello everyone, welcome to this video. So in this today's video, we'll be solving the problem minimum deletions. It's a medium level problem and it is the problem of the day on Geeks for Geeks. And the company tags are Amazon. Okay, so the question is, so given a string of S as input, your task is to write a program to delete the minimum number of characters from the string so that the resultant string is a palindrome. All right, so we all know what is a palindrome. So if we actually go through a palindrome from left to right and the right and then right to left, it appears the same. So that is a very basic layman definition of a palindrome. So the order of the characters in the string should also be maintained. So that is also another condition that has been given. All right, so there have been given some examples, we'll see that later. And the expected time complexity is O of length of string whole square, and auxiliary space also follows the same, but I have used an approach, space optimized approach. I've even showed the brute force technique, like it even works for brute force, because if you can just see the length of this string, that can go up to 10 power 3. So 10 power 3 whole square, 10 power 6 completely works. And now here in this optimized approach, space optimized approach, so auxiliary space, the so-called auxiliary space, the extra space from O of S square, like O of length of S square, I have converted that to O of length of S, just like O of N. All right, so instead they have allowed us to use till O of N square, but I have solved this problem in O of N. All right, so it's a very basic observation that you can use to frame this approach once you understand O of N square space method. All right, so we'll now get into this test cases. So this is the first test case that has been given: A, E, B, C, B, D, A. All right, A, E, B, C, B, D, A. So let us write the string here: A, E, B, C, B, D, A. Okay, so what does the explanation say? Explanation say that remove characters E and D. All right, if we remove characters E and D, E and D, so what is the resultant substring? Resultant string A, B, C, B, A. All right, A, B, C, B, A. Now reverse it. If I reverse it, so this element here A, this element here B, this element here C, this element here B, this element here A. So if we see that ABCBA is a palindrome, isn't it? So if we see from left to right or right to left, so this is right to left, this is right to left, and this is left to right. Okay, the original one, and this is right to left, like we have reversed it. If we can see, this is a palindrome. Why? We could see that left to right and right to left both appears the same. So it is a palindrome, and that is the reason they've asked us to remove the characters E and D. All right, so you can even observe that I can even remove A and A. In that case, what could be the resulting string? C, A and A. If I remove this, BCB would be remain, and BCB is also a palindrome. BCB is also a palindrome, but in this case, the number of characters that we are deleting is 4, and in the previous case, the number of characters that we have deleted is 2. So what is minimum, 2 or 4? 2. That is the reason the output is 2. Alright, there can be various other possibilities as well. You can delete various other characters as well. There is no mistake in that. In the resulting string would also be a palindrome, but they've asked us to find the minimum number of characters that need to be deleted. That is the reason we need to look in that frame. All right, so we'll just remove this now. We have understood like what is the question and what are they actually expecting from us. All right, they are expecting the minimum number of characters that need to be removed. So on clear observation, or at least using the common sense, so the task that we are doing is remove remove characters remove characters such that the resultant string left to right resultant string left to right is actually equal to right to left. Okay, right to left. So remove minimum number of characters or remove characters such that on the resultant string, if I traverse from left to right and right to left, I see the same string. All right, I see the same string. That is what we need to do. So given substring, given string a, e, b, c, b, d, a. All right, a, e, b, c, b, d, a. So if I would like to analyze the things, so what would be my first step? What would be my first step? So I'll just erase these things. I'm putting it very clear just to make sure you people do not end up confusing. I'm explaining each and every minute detail of the approach. That is my main goal. So I have clearly stated in the explanation that I need to remove characters as that the resultant string from left to right must be equal to right to left. So what do you mean by left to right? It's the original string. Original string. That is left to right. Okay. Original string. That is left to right. And that is basically, let me write it with different thing. A, E, B, C, B, D, A. Okay. And now I'm saying from right to left. Right to left in the sense, I mean I'm reversing the string and seeing. Okay. So instead of seeing in this direction, instead of seeing from right to left, if I just reverse it, if I just reverse this thing and then see in this direction, then it's the same thing, right? So instead of seeing from back to left, back to like from right to left, I'm saying I'll reverse the string and I'll go from left to right. That's it. Doesn't make any difference. That is the same thing. So if I reverse the string, reverse the string, if I reverse the string, what would be the result? The result is A, D, B, C, B, E, A. Okay. Now I can go from left to right. Now I can see from left to right. Okay. Now in the original string, anyways, you can travel from left to right. Now in the reversed string also you can go from left to right. So what is the thing? What are the characters that you feel like they're appearing they're same? So A and A is same. B and B is same. C and C is same. B and B is same. And A and A is same. Alright. So we find five characters. Five characters that are same. Five characters that are same in the original string and the reverse string. So what are the remaining characters that must be that must be deleted? So that is basically nothing but the length of the string, that is 7, and the number of characters that are same, that is 5, that is equal to 2. And what are those two characters? Like I'll use a different thing. E and D. Okay, if we remove E and D, the resultant substring would string would be A, B, C, B, A, and in the reverse string also A, B, C, B, A. So yes, it is a palindrome. Okay, so this is the logic. So if we can just reverse the string and see the equivalent characters in both original and reverse and count them, and we can, if we can, those are the things that would appear, like that would be a part of the palindrome. So the remaining characters we can delete it. Okay, we can delete it. So in this case, E and D can be deleted. So if we carefully observe, this is basically nothing but two strings, string 1 that is the original string, string 2 that is a reverse string, and on these two we are applying the LCS. What is LCS? Longest common subsequence. This is a very standard DP problem. Alright, very standard DP problem. So we are just doing it by taking an extra string, and that is basically nothing but the reverse of the original string. Alright, reverse of the original string. And now after this, so we are done and we have got this answer, that is 2. So this is what we need to output. So we'll see that in brief way, like the longest common subsequence. We'll see that now. So for that reason, I've taken a table, alright, A, E, B, C, B, E, D, A. So initially comparing with the empty string, so 0, A comparing with empty string 0, AE comparing with empty string 0, AEB comparing with empty string 0, AEBC comparing with empty string. So this is the comparison, and this is how we are traversing. So AEBC 0, AEBCB 0, AEBCBD 0, AEBCBDA 0. Okay, so 0. So what is this? We are trying to find the longest common subsequence. So how do we find the longest common subsequence? If we find any character same, then we add 1 to the previous, previous I minus 1, j minus 1 block. I minus 1, j minus 1 value. If we do not find anything, we take the maximum of our left and to the top. This is a very tabulation method of the longest common subsequence, very standard thing. Okay, so this is the first row, and now coming to the second. Now comparing these two. All right, now comparing these two. So okay, now when we need to compare this columns, right? This A with the empty string, all those things. So here as well we'll be finding the first column to be 0 0 0 0 because we are comparing it with the empty string. So all these things we are comparing with the empty string. Now come to this. So at this point I find a and a to be same. So whatever the length that I found till now, till my previous, I'll just add 1 because I find a and a to be same. So I'll be adding one more character to the length that I've found till now, to the subsequent, to the palindromic length that I found till now. So for that, I'll just add 1. So 1 plus 0. Here, this is the previous value. Okay, previous value. So from 1 plus 0, I'll be adding 1. Now if you see E, AE and A, AE and A, I see that E and A doesn't match. E and A doesn't match. So what is the maximum that I could find to my left? Maximum that I can find is 11 to 1, and to my right, sorry, to the top, that is 0. So what is the maximum among these two? That is 1. All right, that is 1. That's it. So we are done with this. Now come to B. So B and A, do they match? No, they do not. So what is the max? What is the thing that is there to the left of B? That is 1, and to the top of B, that is 0. So what is the maximum among these two? 1. Same is the case with C. There is no match, so 1. Same is the case with B. There is no match, 1. Same is the case with D. There is no match, 1. Same is the now coming to A. Yes, A match. So what is the previous value? 0. Add 1 to that, I get 1. All right. So we are done. Now coming to this. Now comparing AD with A. Comparing AD with A. D and A match. Does D and A match? No, they do not. So I'll take the maximum among the top and the left side. So here it is 0. Sorry, here it's 1. So here in this case it would be 1. And E and D, does it match? No. So I'll be taking that a maximum among the left and the top. What is the maximum among the left and top? Max of 1 and 1. That is just 1. And coming to B, does it match? No. 1. C, does it match? No. B, does it match? No. And D, does it match? Yes. So add 1 to the previous value. So adding 1 to this value, that is 1 plus 1, 2. Coming to A and D match? No. So take the maximum among the left and the top. So 2. Alright, coming to AB. So now comparing these three with A. So does A and B match? No. So take that maximum among the top and the left. So 1. E and B match? No. Okay, take the maximum. B and B match? Yes. Add 1 to the previous. So 1 plus 1, 2. C and B match? No. So take the maximum. B and B match? Yes. So add 1 to the max to the previous value. 2. D and B match? No. Take the maximum. A and B match? No. Take the maximum. All right. So now comparing this whole this whole thing A D B C. So C matches with A, no, take the maximum. E matches with C, no, take the maximum. B matches with C, no, take the maximum. C matches with C, yes, add 1 to the previous value. B matches with C, no, take the maximum. D matches with C, no, take the maximum. A matches with C, no, take the maximum. All right. And now comparing this whole string A, D, B, C, B with A. So B matches with A, no, take the maximum. E matches with B, no, take the maximum. B matches with B, yes. So add 1 to the previous value. So C matches with B, no, so take the maximum. B matches with B, yes, add 1 to the previous value. D matches with B, no, take the maximum value. A matches with B, no, take the maximum value. Now come to this. So comparing A, D, B, C, D, E with A. So E and A matches, no, take the maximum. E and D matches, yes, add 1 to the previous value. B and D matches, no, take the maximum value. C and D matches, no, take the maximum value. B and D matches, no, take the maximum value. D and D matches, no, take the maximum value. A and D matches, no, take the maximum value. Now comparing this whole string A, D, B, C, B, E, A with A. So starting from this, okay. So very clear, very evident. So does A and A match? Yes. So add 1 to the previous value. So E and A match? No. So take the maximum. So B and A match? No. Take the maximum. C and A match? No. Take the maximum. B and A match? No. Take the maximum. D and A match? No. Take the maximum. A and A match? Yes. Add 1 to the previous value. 5. Alright. So we have got this. We have got this particular value. 5 is the value. So we can even see here that 5 number of characters. 5 number of characters. What are they? A, B, C, B, A. Exactly. So we have got the count through this LCS. So this is basically nothing but the tabulation, right? Tabulation that is followed in finding LCS, longest common subsequence. So we have got 5. So we'll just subtract 7 from 5. That is 7 is the string length. So that these many characters must be removed. All right, must be removed. That's it. So we need to find the LCS, and we just need to subtract that from the string length. That's it. So if we can just go to the brute force method, let us just go through the code. If we can just go through the brute force method. So first then, I've denoted string first with s, and then I've reversed it, and I've put the resultant reverse string into second, and same thing written s dot length, that from the length you can subtract the LCS of first and second. So LCS we have taken n by n, n plus 1 cross n plus 1 cross n plus 1 cross n plus 1 matrix, and the very first row, first row we'll fill it with zeros because we are comparing it with an empty string. All right, empty string. So there is no LCS that could be found. That is the reason 0 0 0. This is first column. Now starting from I equal to 1 and j equal to 1. So if first of I minus 1 is equal to second of j minus 1, if the corresponding characters are same, then add 1 to the previous value. Till now, whatever the value that we have found in the I minus 1, j minus 1 column, add 1 to it. Alright. Else take the maximum of, this is I minus 1 in the sense top, I minus 1 in the sense top, and dp of I j minus 1 means left. Okay. Take the maximum among the top and the left and update it with the dp of, updating dp of I of j, and finally return dp of n of n. That's it. So this is like we are using n plus 1 cross, or I could say n cross n matrix. All right, n cross n. This is O of n square. This is space. All right, this is a space. Now in the space optimized approach, we will not be using it. We'll be using a O of n. Like we'll be taking two vectors, previous and current. But how are we doing it? It's very basic observation. Let us assume I'm calculating the values for this particular row. Okay, I'll just erase these things. It's creating a lot of confusion. Okay, so something I've erased. Yeah. All right. So fine. So let us assume I'm finding the values for this particular row. What are the values that I'm being dependent on? I'm dependent on only this particular value, only on the previous row. Only on the previous row is what I'm dependent. I'm not dependent on any other row. I'm not dependent on this row. I'm not dependent on this row. I'm not dependent on this row. I'm just dependent on the previous row. The previous row itself I'm dependent. So what if I store these values, and once this is done, I'll update my previous with this, and I'll be doing my current analysis on this. All right, so that now this depends only this. Now this depends on only this. It will not be dependent upon this. It's not going to depend upon the first four. It's going to depend upon the previous one. So I'll be replacing my previous with this current current row, and again once this iteration is done, I'll be replacing the previous with this, and I'll be doing the iteration here. That's it. So that's a very simple concept, because our particular row calculation depends on only the previous row calculation. So I need not store all the other values ahead on the top of previous of -1. All right, previous -1, like a current -1. If I'm on the current row, I'm analyzing, I'm doing the iteration on current row, my previous row would be current -1. All right, current -1. So I need not store all the values of rows from 0 to current -2, right? I need not store all these values. So I'll just omit them. So I'll just keep updating my previous. Okay, current -1 is what I'm denoting by previous. So I'll be updating my previous with the current, and then I'll be going to the next row. All right. So this is how I'll be updating myself, and I'll be keeping only the values that I've calculated before. All right, I'll be not be taking all the other values that are not even necessary. Am I using it anywhere in the calculation? No, that is the basic funda. So going here, so basically first previous of n plus 1, and this is basically like n plus 1 sized vector. All the values are 0 0 0. So this is the first row, right? Because every value would be 0 0 0 0 0, right? 0 0. So now coming to the first row, second row. All right, so this is previous. Okay, I'll just erase this stuff. Just a basic dry run. I'll not be doing a whole dry run again. It would just make this video lengthy unnecessarily. Okay, so yeah, so basically now this is initially the previous. All right, this is previous, and this is cur. Okay, this is cur, and now I'm doing the analysis. So if you can carefully see, first this is the previous. Okay, this is the first row, and this is the second row. This is the second row. And now we are doing the same thing. First of I minus 1 equal to second of j minus 1. First of I minus 1 equal to second of. If that is the case, at the corresponding value of j, add 1 to the previous of j minus 1. So what are we actually doing now? This particular thing is denoted by previous. So I see a and a matching, so I add 1 to the previous of j minus 1. Like this is the jth row, right? This is the jth row, so this is j minus 1, so I'll be adding 1 to previous of j minus 1. That's it, right? That is what we have done in the dp, like when we have taken o of n, like this dp method, tabulation, conventional tabulation. When we are doing this n by n cross n matrix, so we have done the same. We are adding 1 to the previous I minus 1 j minus 1 block. So the same thing we are doing here. We have just added 1 to j minus 1 element of the previous stuff. Okay, and what if it's not equal? Let us assume e and a is what we are talking about. If it's not equal, so I'll be taking the maximum among the left. What is the left? That is current of j minus 1, right? This is left, because this is what I'll be, now I'm on this particular position. This is j now, so this is j minus 1, so I'll be taking the maximum of left, that is current of j minus 1, and top. What is top? Top is basically previous of the same row, sorry, the same column, previous of j. This is just jth column, right? So this is the same column, so that is previous of j. I'll be taking the maximum among these two. That's it. So that is what I've done. So if they are not matching, if the first of I minus 1 is not equal to second of j minus 1, then I'll be going into the else loop. I'll be taking the left. What is the left? Current of j minus 1. What is top? Previous of j. And I'll be updating my current element of j with maximum of left and top. And once the iteration of current is done, I'll be updating the previous with current, because now I'm going to the next row. Now I'm going to analyze to the next row. So I need to update my previous with the current values. All right. So after the end iteration, after the complete iteration, after this iteration, after this analysis, now we are updating previous with this particular row results, and we are going to the next. So finally we are storing this particular row results in previous. So that is the reason, and we are interested in this final block value. So that is the reason we are returning previous of it. I've tried to put every minute detail in a very clear fashion. I hope you people understanding what is the essence of this, doing like reversing the string and then doing the LCS on both of them. I hope you people understood. So it's a very, very basic thing. All right. So I've put every minute detail in a very clear way. There's no doubt about it. Even if in this case, if you are facing any sort of doubts, I request you to watch this video once again. Definitely it will be clear to you. All right. So we are doing in a very obvious way. We are using only our common sense to solve this problem. We are not using any sort of logical thinking, to be honest. We are very, very, using a common sense type of thinking, and we are solving this problem. So once this is done, and we will be returning the previous of n. That's it. So this is a space optimized method, and this brute force both are going to work, because the n is the maximum value of n is 10 power 3. So now let us even submit the code for your reference, and it works because I've already checked. And okay, yeah, so it's done. All right, so I hope you people understood. So it's the basic thing. It like boils down to two steps. First, reverse the string and then do the LCS on it, and then just subtract the value from the string length, so that is the number of characters that you actually need to delete. All right, the only observation that you need to do is that once you reverse the string and LCS, if you do it on it, you'll be finding the palindromic palindromic string hidden in it. All right, so it's very common sense also, because you're seeing from left to right. All right, you're seeing from left to right, and you need to see from right to left. That is the palindrome definition. And instead of worrying to see from right to left, what you're doing is you're reversing the string and seeing from left to right. That's it. You're seeing from left to right, and in the original string as well, you're seeing from left to right. And what are you seeing? You are finding those characters which are matching. Which are matching. All right, you're trying to find the maximum subsequence which is actually matching. So that boils down to the very standard problem, LCS, longest common subsequence. That's it. So this is how we can try framing the approach, try aligning the threads, and come to a final answer. I hope you people understood the solution. So if in case there are any doubts, please feel free to comment in the comment section. I'll definitely get back to you. And for your reference, codes in C++, Java, Python have been attested in the description. Please go through them if you are not able to frame the code on your own. So thank you for watching, guys. Stay tuned.